No, that's just a worksheet that you got there. That'll be part of our homework today. So what we're going to talk about today is something called vectors. And vectors can be used for a lot of different things. We used vectors, well, you guys didn't have this, but I used vectors to define operations with negative numbers and how those work using vectors on a number line. A vector is just a fancy word for something that has both a length or a magnitude and direction. So probably the most common vectors used are force vectors. So you might have a force that goes off in that direction with that magnitude. The length of the vector corresponds to the magnitude. And obviously the direction of the vector is the direction. So a shorter vector theoretically has a smaller magnitude than a longer one. Now we don't always get them drawn to scale, but it works out there. And the cool thing about force vectors is geometrically they actually work out. So you can use your laws of geometry on them as well as having to use trig. And I'll show you some examples of that at some point here. For you guys, you might have a phase vector. Something called a phasor in an electronic circuit is a vector. You know, we had the real impedance from the resistor. We had the impedance from an inductor and an impedance from a capacitor. Those are all vectors that add together to give us a resulting vector or a phasor. You know, let's say that we put this one up here. Gives us something like that. So that means the resultant is like that. That's our resulting phasor there. And we'll actually look at how that works before we're done with these. So a phase vector or phasor. A vector can be put on that same grid as our unit circle is. Except we're not going to have the circle on here now. The vector has a tail. The tail is the starting of the vector, the initial point. Then there's a terminal point. So the arrowhead is the terminal point of the vector, the head of the vector, if you call it. So we start here at the tail. Its length would be its magnitude. The angle in which it's going here would be its direction. So let's say I'd have to give you that angle. You wouldn't be able to just guess it. But let's say that's going at 57 degrees. And let's say it has a length of 800 pounds. So it's an 800-pound vector going at 57 degrees direction. And that's how it would be listed. 800 pounds at 57 degrees. Some qualities of these vectors are something called the components. Every vector has vertical and horizontal components. The horizontal component obviously goes horizontally. Vertical, notice I'm leaving a space here. Vertical component goes vertically. What components are there two vectors that can be combined, two or more vectors. If it's three-dimensional, it would be three vectors. In two-dimension, it's two vectors. Two or more vectors that can be combined to be equivalent to that single vector. So here, the horizontal component has to start at the tail. Here's the tail, right? Horizontal component would go this way. I'll put a different color in there so it's a little more obvious. Horizontal component goes this way. Vertical component goes that way, and we end up at the head of the vector. So we end up in the same spot. We just can only go horizontally and vertically to get there. So this is the horizontal component, or what's called the x component, px. This is the vertical component, or called the y component, py. So those abbreviations for horizontal and vertical component, px and py. Px is found by taking the magnitude. Now the magnitude is P. Times the cosine of the angle. The angle is theta. So for this vector up here, that's 800 pounds times the cosine of 57 degrees. Now, if we're going degrees, remember we have to be turned back into degree mode. I'm going to double check that here. I am not. I am in radian mode, so that answer I got was very, very wrong. So let's try that entry again. 800 times cosine 57 is going to give me 435.71. So what that's saying is this direction, that's 435.71 pounds in that horizontal direction. The horizontal component. This piece right here. To get the vertical component, py, it's the magnitude of the vector times the sine of theta, times the sine of that angle. So it'll be 800 here times the sine of 57 degrees. Gives us 670.94 pounds. Okay. So this up here is 670.94 pounds. I'll pause for you. So what I just found there was that component right there. Now as you're catching up, I'll just make kind of a little side note here. You'll notice that forms a right triangle. Like this. This was 800 pounds, right? That's the magnitude of our vector. This was 435.71 pounds. This was 670.94 pounds. Well, I can double check to make sure that's correct, because a squared plus b squared better equal c squared, right? Here's a right angle. Vertical and horizontal are always at right angles to each other. So, what is the square root of 670.94 squared plus 435.71 squared? Probably won't come out exact because of round off, but it should be really close to that 800. And it is 800.002. That's close enough. So yes, that works out. Those components should be correct then. P is the magnitude. Right here, the magnitude. Theta is the angle.
So then you can change that to separate number being negative, so depending on where you're putting it.
Yeah, if they went to the left, it would be a negative for the horizontal. If it went down, it would be negative for the vertical. Yes. Now we can find this angle here, theta. So P is the square root of px squared plus py squared, just as we saw. You can find the magnitude by using a squared plus b squared equals c squared on the components. Theta, if I have the components, you can see this is the opposite side and the adjacent side. That's going to be a tangent. So that's going to be the inverse tangent of Py over Px. If I try that out, let's try it. The inverse tangent of 670.94 over 435.71. Six 7.94 435.71. Better give me about that 57 degrees, and there it is. It is 57 degrees. So that's one of the first things we need to be able to do, is to go back and forth between components and the magnitude and angle notation. Oops. You got that all done? Let me know when you're ready. Okay. Sure. Use the videos later. So let's say I have a vector. The magnitude is 1,200 pounds. And the direction is 120 degrees. Px is 1,200 times the cosine of 120 degrees. Punch that in your calculator. You'll get a negative 600 pounds. We'll interpret that in a second. Py is 1,200 times the sine of 120 degrees. $1,039.23 pounds. Now, why does that make sense? Remember, 120 degrees would be going in this direction, right? So the horizontal component is going in the negative direction. The vertical component is going in the positive direction. Does that make sense? You have to be aware of those positive and negatives when we're going the other direction. Let's say that we are given that Px is 300 pounds and Py is 400 pounds. Let's find the magnitude and direction. Well, the magnitude P is going to be just the square root of Px squared plus Py squared, remember? So that'd be the square root of 300 squared plus 400 squared, which gives us 500 pounds. I'll let you guys punch that in the calculator to confirm that that's 500 if you'd like. Now, I'd said earlier that theta was the inverse tangent of Py over Px. And that's partially correct. Technically, theta ref. Ref stands for reference. That was the reference angle for theta is Py over Px. So the inverse tangent of 400 over 300. Gives us 53.12 degrees. So what does that mean? Well, let's do our little plot here. From the center, I've got 300 in the x direction, 400 in the y direction. That's 500 pounds. This angle is 53.13. So the magnitude and direction for this is just 500 pounds at 53.13 degrees. However, if I had one that looked like this, Px is 1,200 pounds, Py is a negative 500 pounds. My magnitude is pretty straightforward. That's just going to be the square root of 1,200 squared plus negative 500 squared. Otherwise known as 1,300 pounds. The reference angle for P, so theta reference, is going to be the inverse tangent of, which one goes on top? Py. 500 over 1,200. Notice I ignored the negative. 500 over 1,200. So inverse tangent, 500 over 1,200. I'm just dropping zeros because I'm too lazy to type in 4 zeros apparently today. 22.62 degrees. This is a reference angle. Exactly. So we had Px is 1,200, that's right here. Py is a negative 500. So what that means is that 1,300 pound magnitude is right here. This is that reference angle of 22.62 degrees. So to find this actual angle by the picture, and the only way to know for sure is by the picture. The picture tells us that this angle has to be 360 minus the 22.62, giving us 337.38 degrees. That's theta. So this is 1,300 pounds at 337.38 degrees. If I gave you Px is a negative 800 pounds, Py is a negative 1,500 pounds. Yeah. I'm going to trust that you guys can do the a squared plus b squared junk. Get that P is the square root of negative 800 squared plus negative 1,500 squared. That's going to be 1,700 pounds. But yeah, looking at our picture, negative 800 for Px, negative 1,500 for Py. So there's where that 1,700 pounds goes. We do an inverse tangent here for theta ref of 1,500 over 800. $61.93. That's right here, 61.93 degrees. So our actual directional angle is this angle here. How do I find that from the 61.93? 180 plus the 61.93. You got it. That's 241.93. So it's sometimes you have to add that reference angle, sometimes you have to subtract it. It depends on where it is on that little graph. So yeah, this one ends up being 1,700 pounds at 241.93 degrees. Not so bad? Good. Yeah, I mean the tougher part, finding Px and Py is pretty simple. You know, it's just the horizontal is the cosine, the vertical is the sine. It's going the other direction. Finding the magnitude usually isn't a problem. It's that angle that trips people up. And I preach it, draw the picture. Because once you draw the picture, it's pretty obvious. But people try to take shortcuts and say, I can figure it out without the picture. And that's where there's mistakes. You're going to try it without the picture? Well, and I don't necessarily draw out the picture, but I'm a very visual person. So I visualize that graph in my head. If you have that ability, that's what I do. I draw it out in front of class because it's my job to be a little bit obvious. No, not dumb it down, but I mean to make it. I have to display my thought process so you guys understand what the thought process is. Visualizing it inside my head doesn't show you guys anything. Okay, so what if we want to add vectors? Adding vectors can be done in a couple of different ways. I told you vectors can be added geometrically. So let's say I have a vector here. I'm going to write it at the end of the vector. Let's say that this is 800 pounds at, I just put it at 20 degrees to keep it simple. We got a second vector here. Right on the corner there, Carter. You can go in the next room there. It's going right here. Let's say this one is 500 pounds at 75 degrees. The tricky part, if I'm doing these geometrically, is constructing my triangle. What I have to do is I have to take this vector here, and I got to move it. Make it head to tail like this. Adding vectors, remember when you guys weren't with me when we did negatives. When we did positive and negatives, we took the two vectors and put one head to tail. Now it doesn't matter. I moved the green one over by the blue one. I could have done it the other way. I could have taken the blue one moved it up to the green one. Guess what? I end up in the same spot. So what my resultant is here is that vector right there. Well, I know that this length here is 800. And I know that this length here is 500. And I can figure out this angle right here. How can I figure out that angle? Well, if I extend this past right here, I obviously know this is 180 degrees, straight line. This angle here is the difference between the 20 and the 75. Do you see why it's the difference? If I were focusing in on that. If I drew this out flat here, this angle for that vector is 75. This angle here is the 20. So this angle here is the difference between those, the 55 degrees. So this angle right here is 55 degrees. Does that make sense? Oh, crap, excuse me. You're looking stunned. Well, all I did is from this point right here, I drew a line out horizontally here. Like I just moved this up to there, basically. So if this was 20 degrees here, this is 20 degrees here, right? If this was 75 degrees here, this is 75 degrees here. So 75 minus 20 leaves me 55 there. That was given with the vector, and the 75 was given with the vector, yeah. Those are the directions of the two vectors. The 75 and the 20 are given with the vectors. So if I know that's 55 degrees, this here has to be 125 degrees right here. Because 180 minus 55. So what I have there is a law of cosines problem. I can use the law of cosines to find this length here. Once I've got that length, I can find this angle. To get the direction, I have to add it to the 20 degrees here to get the overall direction. So the geometric solution is kind of a bear, and we're not going to use the geometric solution a whole lot in here. What we're going to use is the algebraic solution, just because it's a little bit quicker. Now, don't totally forget this. If we get time, we're going to come back to something towards the end of next week called Bowes notation. Nothing to do with bow, by the way. It's B-O-W-E-S, E''S notation. There are some times where the geometric solution is easier to explain. In many applied force problems where you're looking for a missing force, there are a lot of times where using the algebraic solution requires you have to solve a system of equations. So algebraically, let's add those two vectors. We had 800 at 20 and 500 at 75. What we're going to do for each vector is break them down into components, px and py. So for the 800, it's 800 times cosine of 20 is px at 751.75. Py is going to be 800 times the sine of 20, 273.62 pounds. Does that make sense so far? For the 500, yep, that px is equal to p cosine theta and py is p sine theta. Yep. So this is 500 times the cosine of 75 degrees, 129.41. And py is going to be 500 times the sine of 75, 482.96. Now I need to find a total for both of those. Now these are all positive. Depending on the angle, sometimes they might be negative. Some of the components might be negative. You have to make sure you keep them negative and add them accordingly. So right now this is 6, 11, 11, 8. So 881, 16. That's px of my resultant. I add these up. $756.58. That's py of my resultant. So to find the resultant is just what I get after I add the two vectors. My p is the square root of 881.16 squared plus 756.58 squared. $1161.40. So that's the magnitude of the resultant. Now both of those results are positive. Positive 881, positive 756. So what I get for my reference angle is actually going to be my angle here. My reference angle is going to be the inverse tangent of PY 756.58 over PX 881.16. .65 degrees. So when I add those two vectors, I get 1,161.40 pounds at 40.65 degrees. What do you think? So now the question is, what becomes of subtracting vectors? Yeah. This is why, again, you guys didn't have me when we talked about integers, but when I talk about integers, I stress that you never subtract integers. If we had 8 minus 7, that really is 8 plus a negative 7, right? So if I have two vectors, A, let's say A is, oh, let's just go 1,000 pounds at 60 degrees, and B, where B might be 800 pounds at 110 degrees. If I want to find A minus B, what I am going to do is find A plus the opposite of B. So the biggest question is, what is the opposite of a vector? Minus B. I reverse the direction. You have the right idea. You're just changing the direction. But the reverse direction is found by either adding or subtracting 180 degrees. How do I know whether to add or subtract? Well, if the angle is less than 180, which this one is, we would add. If the angle is more than 180, we would subtract. So opposite of B here is 800 pounds at 110 plus 180 is 290 degrees. So I would just take 1,000 pounds at 60 degrees plus 800 pounds at 290 degrees. And that's A minus B. So I'm just adding the opposite. I feel like I gave you quite a mouthful to work with there today. So you have, for homework, you have that worksheet I gave you, and also in that packet I gave you, it's going to be page 384, 385. 1 through 33, the odds. Remember, tomorrow I am not here. As I try to hold on. On Monday we'll do some applied examples of vector addition. Probably next week, Tuesday, there is a small chance that I won't be here. I'll know for sure on Monday. So then I'll let you know. If I am here Tuesday, there will be a quiz on Tuesday. Otherwise, the quiz will be Wednesday. And we'll have a couple of new things to talk over. Yep. Unfortunately, we will have to have class right up to the final dog on Thursday, just to get you guys through everything. Okay, well.